So the last calculation we're going to do is volume. So still three-dimensional shape, but now like filling in the shape. So we're going to start off finding the volume of this rectangular solid. Now, the easiest way, the most consistent way to always think of volume is we want to take the area of the base and then multiply by the height, because it's like we're filling it in. Think of this, I think the easiest way to think of it is like a Kleenex box. If we had to figure out how much space we can fill that Kleenex box with, think of one Kleenex, like my hand right here is a Kleenex. And we have to figure out the area of that, and then I multiply by the height. I'm filling in all these layers of Kleenexes to fill in the box. So we have to take the area times the height to give it the depth to fill it. Or if you kind of picture like pouring water into something, it's like all these layers of the base, whatever shape the base takes. Like if it's back to my can. This area of a circle, and I put all these layers of area of circle, however many of them being the height, that's filling it in to get at the volume. So we're going to always do it that way. To get volume, take the area of the base times the height. So capital B I'm going to use here to represent the area of the base. So on our formula sheet, actually capital A, let's switch that. Capital A times the height, same for a cylinder. So we'll do capital A. Area of the base. Okay, so the area of this base, so the base, how it's sitting is 6 by 2.5, same as on the bottom. It would be 6 by 2.5 and a height of 3. So the area of the base is 6 times 2.5, which is 15 square feet. So to get my volume, I'm going to take that, 15 square feet, I'm going to write it FT squared, times the height of 3 feet is 45 feet cubed. So notice feet squared times feet is going to be into cubic. All these volume ones are going to be cubic. Now, if you're thinking, oh, well, we've seen this formula of volume before, and we've in the past done LWH, which that works for this. If I do the length is 6 feet times the width of 2.5 feet times the height of 3 feet, multiply those three together, again, we get 45 feet cubed. And that's totally fine. Just keep in mind, though, that only works for box shapes, rectangular solids. So if it's a 6-sided, it's not going to work for all the rest of them that we do. So that you can totally use that shortcut when it's only when it's a box shaped. Okay, like this one, that wouldn't work. You can't just do length times width times height if it's a hexagon. So this one, area of the base, we'll want to, like we talked about the surface area, figure out the area of, actually it's like the front of it, because we have to imagine this turn 90 degrees because that base that's consistent throughout is a hexagon. So area of the base here, and you might have this already written down from doing the surface area, which if you got that, definitely save yourself some calculating. And just pull what you have from when we did the surface area, 31.8255 square inches. Okay, so now to get the volume, I'm going to take that, 25, not 3, 8255. So take the 31.8255 square inches times the height of 6.75, and we get 214.82. Now we're in cubic inches. Okay, next one, cylinder. So if I have a diameter of 18 inches and a height of 30, this one might look familiar too from doing the surface area. So radius is 9, we'll need that. So again, area of the base. So a circle has an area of pi r squared for the formula. So pi times 9 squared. is 254.47 if we go 2 decimal places. And again, you should have this from the surface area calculation, so you can sometimes use that if we also had to find the surface area. So now to get the volume, we take that 254.47 square inches for the area of the base times the height of 30 inches. And we get 7,634.07 inches cubed. Okay, now the next few, all these ones that we just did, we just calculated, didn't really do anything with it. The next two will actually have to have a reason to need to calculate this. So let's say this, we have a piece of steel piping with an outer diameter of 1.5, inner diameter of 1. So piping, I'm going to draw it horizontally like this. Outer diameter of 1.5. Inner diameter of 1. How much would a piece of piping weigh if it's 30 inches long? And maybe I'll just kind of not put an end, because if this was to scale, it'd be off the paper. So 30 inches long, and steel weighs 0.283 pounds per cubic inch. Okay, so if I want to figure out the volume of this so that I have cubic inches and I can then find my weight. So first of all, the area of the base. So the area of the base is going to be just this ring. So I'm going to have to calculate the area of the bigger circle, take out the area of the inside. So I'm going to put just I'm going to put outer area is going to be pi times radius squared again. 1.5 inch diameter means my radius is going to be 3/4. Okay, half of 1.5 is 3/4, 0.75. Okay, I'll take 1.5 divided by 2. And I'm going to subtract the inner area. Pi times, well, if it's a 1 inch diameter, radius is going to be 1/2 inch. And I'm not really including units here, but at this point I'm in area, so this is square units. So pi times 0.75 squared is 1.767, I'm going to go. Pi times 0.5 squared, 0.785. So I have to take off the inside, so I'm going to subtract those. 0.982. So this was the area of the ring. Okay, the area of the cross-sectional view of this piping. Like if we're looking at the piping head on. So now if I take that 0.982 inches squared, the area of the front of that, and multiply by the length, or the height if we turned it 90 degrees. So it's 29.448 inches cubed. Okay, so now to get my weight, I can multiply by 0.283 pounds per cubic inch, and then my cubic inches will cancel, and I'll just be left with the weight. 8.33 pounds. And if we kind of think about this, if it's steel, it's going to be pretty heavy, 30 inches long, it's like 2.5 feet long. That seems reasonable that it would weigh about 8 pounds. Okay, now this one, a couple different things we're going to have to do here. So this one's got a lot going on. If I want to find the weight of this titanium plate in ounces, so first I need to figure out the area of the top. So once I can get the area of the top, and that's going to be the hardest part, then I'll be able to multiply by the height, or the thickness in this case. So again, if we have to think about the base is the shape that's going to continue throughout whatever the height is for 4 millimeters. Okay, so to get the area of the front of this, first of all, before we subtract off the holes, we've got a rectangle and a circle. Okay, so let's get the, I'm gonna just label this as the full area. So for the rectangle part, that'll be 41 times, now looking at the outer radius being 16 millimeters. So if the radius is 16 millimeters, that means the diameter from here to here would be 32. We have to double that. So I've got 41 by 32. Okay, and then I have 2 half circles, which will make a full circle. So pi times radius squared. So there, we're going to use that 16. So the rectangular part, 41 times 32 is 1312. And this is going to be millimeters times millimeters, so we're going to be at square millimeters. And then pi times 16 squared is 804.25. And if you put that all in one step, you could maybe have skipped this one we just jotted down and get straight to, and I apologize, I was off the screen for a second, 2116.25. So that would be if there were no holes. So I could, from there, I could have just then multiplied by the height of 4 millimeters, but I have to take off those circles. So for each of these, so I'm going to subtract, okay, so I'm going to just label this as the holes. I'm going to have to subtract a couple different areas. So the first one, I'm going to have a pi times 5 squared. I'm just going to put that. We're going to subtract that one. And then I'm going to have a pi times 10 squared. And then another pi times 5 squared. So those pi times 5 squareds are 78.54. And then the pi times 10 squared is 314.16. So 2116.25, subtract the 78.54 twice in the 314.16, and we're at about 1,645.01 millimeters squared. Okay, so that's the top now with the circles taken out. So now to get the volume, I can take that and multiply by the height to give it that filling it in by 4 millimeters. And I have a volume of 6,580.04 millimeters cubed. Okay, now one more step because we want to figure out the weight of this. So we're given that titanium weighs 2.59 ounces per cubic inch. So I'm going to have to do some converting here. So I'm gonna go over here. So I have 6,580.04 millimeters cubed. Okay, so I'm going to have to convert millimeters cubed to inches cubed. So we're given that a cubic inch is 16,387 cubic millimeters, or use your formula sheet. That one's on there. And I'm going to go another step. I'm going to keep going to get to that weight. I'm going to do inches cubed to ounces. So 2.59 ounces per 1 cubic inch. So take my 6,580.04 divided by 16,387 times 2.59, and I get 1.04 ounces.